Greetings, YouTube. My name is Ed Gomez, and I'm a senior .NET developer and lead architect with over 30 years' experience in software development. I've worked at many major financial institutions, and I've done this for a while. Everything I'm about to teach you comes from real-life experiences. I'll take the theories and concepts and show you their practicality in business uses. If you like this video, please remember to like and subscribe and hit the notification icon to be notified of new content. Okay, so in the last lecture, we discussed the open-close principle. Now let's discuss the Liskov Substitution Principle. So what is it? In the very first video, we went through all of the S.O.L.I.D paradigms and all of the definitions, and this one will just cover the simple translation. You should be able to substitute an inherited class in place of its base class. An inherited class must not change the initial implementation of the base class. Now, let's look at a Liskov substitution example. I have a rectangle class. The rectangle class has a length and a width, right? It also has another method, create standard lot. It's its own little method there, okay? Let's look at a square. In a way, a square is very much like a rectangle in that both have a length and width. However, a square requires all sides to be equal. So why not merely inherit from a rectangle and impose this restriction, right? Okay, so I inherit from rectangle and I pass the length twice as length and width into rectangle. I have a unit test here. This is my Liskov test feature. And in there is a method which you saw when we did the rectangle. In this case, this object called rectangle has a thing called create standard lot. So I'm in Visual Studio, and I hit F5, and I run this thing from my test case, my test suite. So it crashes. It just so happens that there's a method for calculating a standard lot in the rectangle object, which requires the length to be longer than width. We didn't know of this restriction, and we tried to violate the Liskov when we first inherited, I should say. When we first inherited from the rectangle class, we didn't know of this restriction, and we tried to violate the Liskov principle by attempting to make a base class do what it was never intended to do. But we knew that a square must have the same size, which is not a restriction for a rectangle, so we should never have inherited from it. I'm giving you a very rudimentary example because everybody knows a square and a rectangle, okay? But there are going to be things. In this case, we had an object, and an object of a rectangle doesn't have a create standard lot, but there was an object that we had created in the form of a rectangle. All right, it just said its properties were length and width, but it also had a function called create standard lot. Maybe this was some sort of geometric application that we were using to do things, and we had to come up with something else. Maybe we were coming up that was being used, let's say, for a rectangular lot size, where now we had something new coming in for a square lot size or something like that. I'm just giving you some rudimentary example of something out there. It's easy to follow. So that's for a square and a rectangle for objects. But what if this was some real life situation? And this is going to happen a lot, where you see commonality and you figured, you know what, I'm going to get lazy, or maybe I can not so much get lazy, but I want to reuse it, because that's the whole point of object-oriented programming, is the reusability. Here's a very great site, Investopedia. If you want to know anything about financial terms or anything like that, go to this site. In there, I just happened to find an article from Chad Langganger. I believe that's how he spells his name, Langgager. I apologize if I mispronounce it. This was done on May 1st, 2019, about the differences between a zero coupon bond and a regular bond. And basically, a zero coupon you buy it at a discount, and when it reaches maturity, you sell it for more money. So you bought it at $100, and let's say 2 years later, you could sell it for $500. Okay. A normal bond, however, gives you coupons, and you can redeem them throughout the cycle of the bonds. So that's how you get your interest payments. You know, like stocks pay dividends. Well, normal standard bonds pay. They pay by coupon. You just redeem the coupon. Okay. So here's a situation now where you figure, oh, it's a bond. A bond's a bond. No, these are different types. I gave you a very simple explanation between a square and a rectangle. But in real life situations, you're going to find objects that relate to one another, but you can't imply the restriction. If I start out with a regular bond, and I have an object out there, and now I want to inherit it, and now what I want to do is now I want to make a zero coupon bond because they're basically the same. They're going to have maturity dates, they're going to have prices, they're going to have all sorts of stuff that's basically almost the same. The only difference between the two is that when it comes to processing the coupon. So why can I use it? Well, because the bond requires that it has the coupon. I shouldn't be taking away the coupon to make a strip coupon. And that's where the Liskov substitution comes in. Now, you can probably get away with this. You'll code this, and this thing will be running for months, maybe years. But it's going to come back and hit you in the face. The moment that you take an object and you inherit it, and in your inherited object, you're imposing restrictions that the base class didn't have, you're going to get yourself into trouble. You may get away with it for the longest time and not notice anything, but what will happen is your application, in a real-life scenario, your application gets used, it's going to be very difficult to spot these different things. It's like, I gave you the case of creating the standard lot. There'll be other methods that most likely this regular bond has that you're going to call this function to do certain things that just won't work anymore because you've taken out the restriction that it had that is supposed to have coupons on it, and you made it zero. So I'm hoping that I gave you a very simple example of why you shouldn't violate the Liskov substitution principle. I gave you an example of a square and a rectangle, and I also provided you a real-life scenario of using a financial object such as a bond and trying to make a bond and taking away the right of it to have coupons and create a zero coupon just because you wanted to reuse it. You're actually taking away functionality. What you should get from this whole thing of the Liskov is never inherit from a base class and take away the base class functionality in your inherited class. And the links from my book titled Software Development Accelerated Essentials, What You Didn't Know You Needed to Know, are available below. Just take a look at the table of contents to see the wide range of topics I discuss. The book is broken down into two components: building the company, which is how to develop maintainable code, and running the company, which includes production releases, data warehousing, job scheduling, and so much more. So whether you're a developer or an IT manager, there's lots of information available for you in a one-stop shop resource. Please consider leaving me a review at those links, and thanks in advance.